Hi students, in the last class we discussed how to calculate the HCF by using Euclid's algorithm. Okay, now in the exercise 1.1 we have some more questions. So here we use Euclid division algorithm to prove these all. Okay, so here let us discuss one by one, and you should listen concentratedly. That will be very easy to you. So let us go with first one. So that is second question. Use division algorithm. Use division algorithm to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay. So here you know that integers. You know that in positive or positive integers means you know that 1, 2, 3, yes, 4. These are all positive integers. Already you know that any number is either even or odd. So we take 2, 2 is even. We take 1, that is odd. 3 is even, now 3 is odd, and 4 is even. Yes, 5 is odd. So here means even number, odd number, even number, odd number, even number, odd number. Okay, so you know that any odd integer, any integer is either even number or odd number. There is no other option. Okay, so we have to prove that the odd integer, positive odd integer is in the form of either 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Where q is some integer. So for proving this we use division algorithm. Okay. So first of all, already you know what is division algorithm. For any two positive odd integer a and b, there exists unique q and r such that a equal to bq plus r. So that is the division algorithm. Already you know that. So let us discuss the first question. That is second in this exercise. Use division algorithm to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay. So I'm taking the white space to discuss this problem. Okay, just here, before going to solve this problem, you should have idea what is form of even, what is general form of even number, what is general form of odd number. That is 2n is even and 2n plus 1 is odd. Okay, so here, first of all, you observe this one 6, 6, 6. Okay, so here by using this, by observing this coefficient of this quotient, we have to assume the b value. How you take, let's see. Now see, according to Euclid division algorithm by EDL, Euclid division lemma, a equal to bq plus r, where here the condition is 0 less than or less than b, and a comma b are positive integers. Okay, so z plus I'm writing, so positive integers. Now here, first of all we have to assume for b value. So if you observe here in the question, if it is given 6q plus 1 and 6q plus 3, 6q plus 5, so we have to take b as 6. For example, if the question it is given 8q plus 1, 8q plus 3, so in that case you have to assume b as 8, and the compulsory you will be given only even coefficient only. You won't, never will be given 7q plus 1, 7q plus 3 like that. Okay, so you'll be given either 6q plus 1, 6q plus 3, 6q plus means your coefficient is 6 or 2 or 4 or 8 or 10. Okay, we are already given 6. Okay, so that's you can observe. In the examination also, the question is changed. Will be given only these coefficients only. Okay, in the place of b. So we have to assume that b equal to 6. Let b equal to 6. When b equals 6, what is the property of the remainder? That is 0 less than or less than 6. Okay, so you know that when you divide any number with 6, so we get the remainders. What are the conditions? What are the possible remainders? That is, some cases we get 0 or 1 or 2 or 3 or 4 or 5. Already we have written here. So r equal to 0 or 1, 2, 3, 4, 5. Okay. So possible remainders are 0 or 1 or 2 or 3 or 4 or 5. Okay. So now first case. So here how many remainders are there? Here totally 5 remainders are there. That's why we get 5 cases. So next here this here we have to substitute 6 cube plus 0, first one. Second one is 6 cube plus 1. So the third one is 6 cube plus 3. Okay. Fourth case 6 cube plus 5. Sorry, 6 cube plus 4. And all. Okay. Let us take the first one. Case 1. When r equal to 0. When r equal to 0. What do you get? We get a equal to 6q plus 0. So here now after writing this, what to do? So we have to convert this form either into 2n or 2n plus 1. Okay. So what is possible here? You can write 6 as 2 into 3. Okay. So that is nothing but 2 into n, where n belongs to z. Okay. So for any here 3 into q we get an integer. That may be any number. So 2 into some number is always even. So this is our even number. So means that 6q is converting into even number. So therefore what you can write, a equals 6q is even. Okay. A equals 6q is even number, or you can write 6q is even number. Okay. You are writing a equal also. You can write that simply. Therefore 6q is even. Okay. Now let us take the case 2. Case 2 wanted to take the second remainder. Okay. What is second remainder? When r equal to 1. So when r equal to 1, what to take? A equal to 6q plus 1. Okay. So 6q plus 1. Now what do you get here? Now we have to convert into the form of 2n or 2n plus 1. Here you can observe here plus 1 is there. So we can convert into the second form. So a equal to 2 into 3q plus 1. Okay. So that is 3q is some integer. You can a into 2n plus 1. Okay. For n belongs to z. Okay. So now here this is which form? That is odd form. Okay. So therefore the given what I have taken here we are taking 6q plus 1. 6q plus 1 is odd. Okay. Now let us take the case 3. Case 3, how do you take when r equal to 2? When r equal to 2, again a equal to get 6q plus 2. So here we get, here 6 is there and 2 is there. So we can take 2 as common number. 2 into 3q plus 1. I think you understood here. 2 3 is 6 and 2 1 is 2. Okay. So I have taken 2 common from these both terms. So here this is again some integer. So a equal 2 into n. Okay. Where n belongs to z. So here therefore 6q, now this is which form? Even form. So 6q plus 2 is even. And case 4. What is case 4? When we take r equal to when r equal to 3, okay, and we get a equal to 6q plus 3, and the common number is 2. Here we don't get 2 as common. Why? Because here 3 is there. So this 3, how can you write 6q plus 2 plus 1? If you write 3 as 2 plus 1, now in the first two terms we get 2 common. 2 into 3q plus 1 plus 1. Okay, now 2 into some integer plus 1. 2 into n plus 1. For n belongs to z. So here which form it is? R form. Therefore 6q plus 3 is R. Okay, now let us go for another case. Case 5. I'm writing here. When r equal to 4. Okay, when r equal to 4, what do you get? A equal to 6q plus 4. That is 2 into, here we get 2 common in the both terms. 2 into 3, 6 plus 2 to the 4. So 2 into some number, some integer. Okay, for n belongs to z. Okay, so this is which form? Even. Therefore 6q plus 4 is even. Again, in the last case, we have completed 0, 1, 2, 3, 4. Now we have to take 5. So case 6. When r equal to 5, what do you get now? Again, we get a equals 6q plus 5. That is, how can we write? 6q plus 5, how can we write? 4 plus 1. Now 2 into 3q plus 2 plus 1. 2 into some integer plus 1. So this is odd, which is now here this is odd form. Now therefore what can I write? 6q plus 5 is odd. Okay, after writing all this, you can observe that 6q plus 1 is odd, 6q plus 3 is odd, 6q plus 5 is odd. So that is the conclusion we can make. 6q plus 1, 6q plus, now here what is going in the question? 6q plus 1, 6q plus 3, 6q plus 5. These all 3 must be odd. So we got the same. So what we can conclude from above cases, what we are taking a positive integer a, okay, so that's why I'm taking b equal r. So from that we got all the 6 cases. Means when you take b equal 6, the number is either 6q plus 0 or 6q plus 1, 6q plus 2 or 6q plus 3 or 6q plus 4 or 6q plus 5. Among these, which are odd? 6q plus 1 is odd, 6q plus 3 is odd, 6q plus 5 is odd. So this we can conclude, we can write what is given in the question. You can observe and write. Okay, this from here to here. So any positive or integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. Okay, so that is the question. Okay, and this is very simple to write. We have to take the reminders and we have to write all the cases. Okay, sometimes if you don't have time, we can write it directly also. Yes, that's I tell you. How to write directly? Very simple. First of all, you have to mention the Euclid division algorithm. For by using by ETL, Euclid division lemma, Euclid division algorithm, a equal to 6 cube, b cube plus r, and the condition 0 less than or less than b. Okay, where a, b are positive integers. Now we have to assume b equal to, let b equal to 6. If 6 is given, I'm taking 6. Okay, so when b equals 6, therefore remainder equal to 0 or 1 or 2 or 3 or 4 or 5. You should write all this. A equal to 6 cube plus 0, a equal to 6 cube plus 1, a equal to 6 cube plus 2, a equal to 6 cube plus 3, and a equal to 6 cube plus 4, a equal to 6 cube plus 5. Okay, this here also you can write very simply. 6 cube, that is 2 into 3 cube, that is 2n, that is what? Even. This one how can you write? Here we don't get common. So 2 into 3 cube plus 1. Here 2n plus 1, that is odd. And here we get 2 common. 2 into 3 cube plus 2 into 3 cube plus 1. That is 2n. What is that? Even. And this is 2 into 3 cube. And here we can write 3 as 2 plus 1. So that is 2 common again. 2 into 3 cube plus 1 plus 1. That is 2n plus 1. What is it? Odd. Okay. So here we can write 2 into 3 cube plus 2. That is 2n. That is what? Even. And this is, here we have write 6 cube plus 2, 4 plus 1. Now we get 2 common. 2 into 3 cube plus 2 plus 1. That is 2n plus 1. This is even. Odd. So we can conclude, now we can write conclusion. Okay, you can do in this way also. Okay, so if you are not able to take all the cases, means I have written all together, okay, in one line. Okay, so if you write like this also, then you get the, can score the marks. Okay, and the question, how it will be changed. So instead of some cases you will be given, if you're given, for example, the same question, if you want to use division algorithm to show that any positive odd integer is of the form, if you're given 8 cube plus 1, 8 cube plus 3, 8 cube plus 5, 8 cube plus 7. Okay, hence the quotient is changed to 8. You will be given odd form is 8 cube plus 1 or 8 cube plus 3 or 8 cube plus 5 or 8 cube plus 7. If you are given even, the same question is given for even, then you will be given only 8 cube or 8 cube plus 3 or 8 cube plus 4, 8 cube plus 6. Okay, that's all. Okay, so if the question is changed, means depending on the question, they will be given this. It may be given 10 or it may be given 4. And I think in example questions you have given, this same problem is given for 4. Okay, question 4. So when you take the B as 4, what do you get? Cases 4 cube plus 0, 4 cube plus 1, 4 cube plus 2, 4 cube plus 3. That's all. Okay, means this is even, this is odd, even, odd. Okay. So you should understand the concept here. First of all, you should understand the concept. Then not practicing this. Okay. So if you know the concept, no need of practice. Just keep in mind. Okay, let us go for the second one. Means the third one. Use division algorithm to show that the square of any positive integer. Now here directly given only any positive integer, but here what is given? The most important thing is square. Square of any positive integer. Okay. So while you're reading the question, you should read it carefully. Square of any positive integer. The square of any positive integer is of the form 3p or 3p plus 1. Now, how do you do this problem? Let's see. So this is, here we have to consider the square. That's why we should know the square of an algebraic identity. So you know that a plus b whole square. Yes. So a plus b whole square or a minus b whole square. So here we get a plus b whole square. We have to use a plus b whole square. Okay, now how to take that? Again, first of all, we have to write by using EDL. Okay, by using division lemma or division algorithm. A equal to PQ plus R, and here condition 0 less than or less than B. Now, what have to take the B value? So here we have to take B value as 3. Let B equal to 3. So therefore, what are the remainders? 0 or 1 or 2. Okay. So when I take B equal to 3, we get remainders only these 3 remainders. Okay. So what will be the numbers? 3q plus 0. So I'm taking the cases. Case 1 and case 2, case 3. Case 1, what is case 1? What is case 1? That is A equal to B cube. Means here B, what I have taken B? 3. So I have to write 3q plus 0. Means the remainder I am taking as 0 when R equal to 0. A equal to 3q plus 0. Okay. And here when R equal to 1, A equal to what get 3q plus 1. When R equal to 2, what get A equal to 3q plus 2. Okay. Now, but here what to take? We have to take square. So squaring on both sides. Squaring on both sides. So you have to square on both sides. A square equal to 3q plus 0 means 3q only. So 3q square. I'm writing here. Squaring on, we can write total, you can write full form. Squaring on both sides. Okay. So here also a square equal to 3q plus 1 whole square. Here also a square equal to 3q plus 2 whole square. This should write the statement squaring on both sides. Okay, now here, what do you get here? A square equal to 3q whole square. Now, we have to get either 3p form or 3p plus 1. Okay, so 3 into some integer or 3 into some integer plus 1. Okay, now what do you get here? A square equal to, you can here write here 3 square is 9, q square. Okay, 9q square. This how can you write? 3 into 3q square. Okay, so here 3q square some integer, so 3 into p, where p belongs to z. Okay, now the first one we got 3p. First one we got 3p form. Now let's go for the second one. Here we have to use a plus b whole square expansion. What is a plus b whole square? A square plus b square plus 2ab, or you can write a square plus 2ab plus b square as a wish. Here I use a square plus 2ab or plus b square. Now a square equal to a square equal to, so if you use this form a plus b whole square, what do you get? 3q whole square plus 2AB, 2 into AB. AB means 3Q and 1. Okay. And here 2AB plus 1 square. Now what do you get here? 9Q square, 2 3 are 6Q plus 1. Now here which form we get? We get 3P plus 1 or 3P. So you can observe here plus 1 is there. So we get exactly this this form. So we take 3 common in the first two terms. 3 into 3Q square plus 2Q. Okay. So here this is some integer 3 into P plus 1 for P belongs to Z. And third case, here also A square equal to again A plus B whole square. A square plus 2AB 2AB 2 into 3Q into 2, okay, plus B square. So we get 9Q square 6 to the 12Q plus 4. Now which form we get 3P or 3P means here compulsory 3 we have to get common, but with 4 here 4 is there, we know that 3 will not divide 4, okay. So this 4 how to write? 9Q square 12Q plus 3 plus 1 I am writing. Now in the first 3 terms we get 3 common, 3 into 3Q square plus 4Q plus 1. Here we know that 3 divides 9, 3 divides 12, 3 divides 3. That's why I'm taking 3 common. 3 into 3, 9Q square, 3 4s are 12Q, 3 1s are 3. Okay. Plus 1. Again, what to go? 3P plus 1. For P belongs to Z. Now, if you observe carefully from this all the 3 cases, so here what we got? We got the square of a number is of the form 3P or 3P plus 1 or 3P, that's all, okay, only 2 forms. So here what I can write is by above cases, we have to write again this one, the square of any positive integer is of the form 3P or 3P plus 1. For any problem, compulsory you should write the conclusion. Okay. So the conclusion is the most important thing. Okay. That is square. So here last and the ending you should write this conclusion, the square of any positive integer of the form of 3P or 3P plus 1. And this is third one. Now let us move to the next one. Here what is given? It's cube. Cube of a positive integer. So you know that if you want to do the cube, you should know A plus B whole cube. What is A plus B whole cube, do you know? I think most of the students okay, now we discuss the fourth one. The fourth one is cubing. So in the third problem, we have discussed the squaring of a number. Yes, the square of the number is in the form of 3P or 3P plus 1. Now we have this problem, that is, you can observe here, that is cube. Okay, that is the thing here, a cube of a number. So, but here, what you take about B value? So, do you take 9? If you take 9, you will get 9 cases. That is very, that will take much time to complete that. That's why, first of all, let's start the problem by EDL A equal to BQ plus R, 0 less than or less than B. Okay, now here we have to assume B equal to 3. We take 3, okay? Then we get remainder 0, 1, 2. That's our only 3 cases. So now we take the first case, case 1. When r equal to 0, okay? When r equal to 0, we get a equal to 3q plus 0, okay? Now cubing on both sides, you have right there, cubing on both sides. Right here, cubing on both sides in the bracket of. Now here, a cube equal to, why I'm cubing? I think you understood. Here, cube of any positive integer. So we have to take cube. So here, 3 cube, that is 27. 3, 3 and 9, 9, 3, 27. Now we have to get either this form, 9m, or 9m plus 1, or 9m plus 8. Depending on this, okay, depending on this value, we can decide which form we get it. Okay, so here you can take 9m. We get 9m. 9 we can take 9 into 3, 27 cube. So this is some integer. So 9m, where m belongs to z. So m, I have taken m equal 3q cube. Okay, that is a cube. And next one, case 2. When r equal to 1. When r equal to 1. Now here, what we get? A equal 3q plus 1. Okay. So here again cubing on both sides, 3q plus 1 whole cube. How do you expand this? So a plus b whole cube, by using a plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square. You should know this identity. Okay, here we get 4 terms. A cube plus b cube plus 3a square b plus 3ab square. So here a cube, what is a cube? 3q whole cube plus b cube 1 whole cube 1 cube plus 3a square. A means here 3 cube, okay? 3q square whole square into b. B is 1. Next 3ab square. A is 3q. B square means here 1, okay? 1 square. So 3q cube, that is 27q cube plus 1. And here we get 3 square is 9, 9 3 27. 27 q square. 1 square is 1. 3q into 1, 3q. 3q into 3, 9q. Now which form you get? We get 9m form. Okay. You don't get 9m form. Why? Because here 1 is there, plus 1 is there. You know that in this 27 is divisible by 3. Okay. And 27 here again 27 also divisible by 3 and 9 also divisible by 3. That's why in these 3 terms we get 3 common, but plus 1 is there. That's I'm writing at the ending. 27q cube plus 27q square plus 9q plus 1. Okay. Now here in the first 3 terms we get 3 common. Not 3, 9. 9m plus 1 we get. So 9 common. So we get 9 into 3q cube plus 3q square plus 9. Here we get q plus 1. Okay, 9 3 27 q cube, 9 3 27 q square, 9 9 into q, 9q. So after writing common thing, just you have got to check like this. Okay, then if you did any mistake, you can correct it. So here we get 9 into m plus 1, where m belongs to z. So this is which this one second form we got. The first one is in the form of 9m, second one is in the form of 9m plus 1. Now I think for third case we get this form. Okay, let's see here. Let's check case 3. Case 3, when r equal to 3. Sorry, when r equal to. When r equal to, what do you get? A equal to 3q plus 2. So I have taken 3, b value 3, and remainder 2. So a equal to bq plus r means 3q plus 2. Again, cubing on both sides. aq equal to, again this form. The two terms are there. A plus b whole cube we have to use. So here a cube plus b cube plus 3a square b plus, I'm writing here, 3a b square. So while you're doing simplification, do carefully. Here 27 q plus 8 we got. Here 3 square is 9. 9, you see here 3 square is 9. 9 2 is 18. 18 3 is 54. 54 q square. And this one 3 3 is 9. And 2 square is 4. 9 4 is 36. Okay. So here, if you observe this one, plus 8 is there. Plus 8 means this one, third form. Okay, so we write the remaining three terms together. 27 q cube plus 54 q square plus 36 q plus 8. So in this all we get 9 common. 3 cube, 6 q square, 9 4 is 36. So we get 9m plus 8. Okay, so for m belongs to Z. So we got 9m plus 1, 9m plus 8. So we can conclude this. From above cases, what you can write from here to here, cube of any positive integer is in the form of 9m or 9m plus 1 or 9m plus 8. Okay, this is the conclusion. So I think you understood that the third question is squaring and this fourth one is cubing. Yes, cube of a number. And this is statement you have to remember, and that is most important in objective also. Okay, cube of any positive is in the form of dash. Okay, you can write 9m or 9m plus 1. So 9m plus 8 means it will be given in the multiple choice question. Okay, this is 9 is here, 9 is given. That number may be also changed, but as your 10th level, the number may not change. Okay, now here we go for the last question in the exercise, that is 51. So if you read that question, show that one and only one out of n or n plus 2 or n plus 4 is divisible by 3. Means n is a number. Okay, n is any positive number. For example, let us take let us assume n equal 5. N equal 5 means here what you get 5 n plus 2 n plus 4. So if you take n equal 5, n plus 2 is 7, n plus 4 is how much? That is 5 plus 4, 9. So among these three, only one is divisible by 3. You know that in 5, 7, 9, 9 is divisible by 3. Okay. So means here what is given? Show that one and only one out of n or n plus 2 or n plus 4 is divisible by 3. So either n is divisible by 3 or n plus 2 is divisible by 3 or n plus 4 is divisible by 3. Okay. So here if you take, let's take some other number, n equal 10 I'm taking. N equal 10 if you take, we get n plus 2 as 12, n plus 4 as 14. Now you know that 10 is not divided by 3. Okay. And 14 is not divided by 3. And 12 is divisible by 3. Okay. So I think you understood that. So here either n or n plus 2 or n plus 4 is divisible by 3 when n is a positive integer. So how to prove that? Again, we have to use Euclid division algorithm. Okay, so I'll discuss that now. So to prove this, we have to assume for n. Okay, so here n is a positive integer. So here again by EDL, Euclid division algorithm, or Euclid division lemma, a equal to b cube plus r, 0 less than or less than b. Okay, now here let's take n is here instead of a, I'm taking n. Okay, n equal to b cube plus r. Okay, now here I'm taking b as 3. I'm writing here, assume b equal to 3. So remainders what you get? 0, 1, 2. Okay, so now here when you take first case, take first case, case 1. So here when r equal to 0, when r equal to 0, what do you get? N equal to 3 cube plus 0. Okay, so means n equal to 3 cube. Now in the first case, now n equal 3 cube we got. Now this 3 cube is already that is multiple of 3, that is divisible by 3. So when you take n equal to 3 cube, and now if you take n plus 2 and n plus 4 also you have to discuss. Okay, so here this divisible by 3. This is divisible by 3. But n plus 2, what is n plus 2? 3 cube plus 2 is not divisible by 3. Okay, n plus 4, 3 cube plus 4 is not divisible by 3. Okay, now let us take case 2. Case 2, what you take when r equal to 1? Now what you get here? N equal to 3 cube plus 1. 3 cube plus 1. Now, you know that this is not divisible. So here what? N equal to 3 cube plus 1 is not divisible by 3. Okay, but let us take n plus 2. What is n plus 2? N is 3 cube plus 1 and plus 2 is there. That is 3 cube plus 3. That's we get 3 into cube plus 1. This is divisible by 3. Now if we take n plus 4, 3 cube plus 4 we get. Okay, so 3 cube plus 4 is, here we don't get 3 common. So is not divisible with 3. Now let us take case 3. When r equal to 2. So when r equal to what you get? N equal to 3 cube plus 2. Again we have to write this form. So here n equal to 3 cube plus 2 is not divisible by 3. And n plus 2. 3 cube plus 2 plus 2. That is 3 cube plus 4 is not divisible by 3. Right here same. And n plus 4, let us take n plus 4. 3 cube plus 2. So n is 3 cube plus 2 and plus 4. So 3 cube plus 6. Here you know that 3 is common. 3 into some number. So this is divisible by 3. So in the first case, we got only n is divisible by 3. In second case, n plus 2 is divisible by 3. In third case, n plus 4 is divisible by 3. So from all the cases, what you can conclude from above cases? So only 1 out of n, n plus 2 or n plus 4 is divisible by 3 when n belongs to z plus positive integer. Okay, that's all. So this is the first exercise. Okay, and the last one is somewhat different. It is, so here for every case again we get discuss that form n plus 2 n plus 4, n plus 2 n plus 4. Okay, n plus 2 n plus 4 means you're taking n as a number. Okay, instead of a, I'm taking n as a positive integer. So I'm taking b as 3. So here we get 3q plus 0, 3q plus 1, 3q plus 2. Three cases. Again, in the three cases, you have to write all these three forms. And you can, if you're getting multiple of 3, then the divided by 3. Otherwise, that is not divided by 3. Okay. So that is the first exercise. Thank you. And we discuss the remaining in the next coming videos. Okay. Bye.